In the Unit 3, Lesson 5 notes, we are just going to review how to evaluate some limits where delta x is approaching 0. Okay, so looking at this first example, it tells me to find the limit as delta x approaches 0 of this rational expression. Okay, so the first thing I'm going to do is break this into chunks. Let's just focus on f of x plus delta x first. Really, if I want to figure out what f of x plus delta x is, everywhere I saw an x in this function before, now I'm going to be replacing x with x plus delta x. Okay, so here instead of seeing x, I would see x plus delta x squared. All right, it takes care of that term, plus 2. Again, instead of x, I'm going to see x plus delta x. All right, then we have a minus sign, so the minus sign comes next. All righty, then I have to put in my function. Remember, when you're inputting your function, since it follows a subtraction sign, it's really important that it goes inside parentheses. Okay, my function, if I just look over here, my function was x squared plus 2x. All over, and you can see that it's all over delta x. So now I just have to multiply some things out and simplify. We'll have the limit as delta x approaches 0 of, let's break this into chunks. The first thing I see is x plus delta x quantity squared. Just over here as a side note, okay, we have x plus delta x quantity squared. Squaring something really just means that I'm taking that something and multiplying it by itself. So if I were to distribute, we would get x times x is x squared, outer times outer is x delta x, inner times inner is another x delta x, and last times last is delta x squared. So really you can see in the middle here, I actually would end up with 2 of those x delta x's. Okay, for whatever reason, when I've had students in the past square this expression, rather than writing x squared plus 2x delta x plus delta x squared, they like to leave out that x in the middle. Like they'll write it like this. See how there's leaving out the x right here? Be careful of that. You want to make sure it's 2 of those x delta x's. Don't leave out the x there or you're going to run into problems. Okay, so let's go ahead and input that for x plus delta x squared. So right here, we just expanded that. We got x squared plus 2 of those x delta x's plus delta x squared. Okay, so that's done. Then we have a plus sign, right? So I'll put a plus sign there. Then we have 2x plus delta x. So I'll distribute the 2 through and I will get 2x plus 2 delta x. Then we have this minus sign. And remember that minus sign, it gets distributed to both of the terms inside the parentheses. That's why it's so important to remember these parentheses. You might even want to make a note to yourself. Don't forget parentheses, because if it follows a subtraction sign, you need to distribute through to both terms. We get negative x squared minus 2x. Now this looks long and ugly, but I should expect that some things will cancel. For example, here we have x squared minus x squared. That goes away. 2x and negative 2x becomes 0. That goes away. And that's really it, right? What am I left with after that cancellation? We're left with 2x delta x plus delta x squared plus 2 delta x all over delta x. Okay. Now the numerator is not factored right now, so before I can do any more cancellation, I need to ask myself, can I factor the numerator? In this case, there is a greatest common factor. The greatest common factor is delta x. See how all 3 terms have delta x in them? If I divide all 3 terms by delta x, that would leave me with 2x plus delta x plus 2. And now that I have a factor, delta x, in the numerator, I can cancel it with the delta x in the denominator. Okay, and that's just 1. So I'll get the limit as delta x approaches 0 of 2x plus delta x plus 2. Okay, notice my limit notation, I carried it all the way down because I have not plugged in 0 yet for delta x. Now that I'm plugging in 0, right, for delta x, I can drop that limit notation. We get 2x plus 0 plus 2, and so my final answer here would be 2x plus 2. Okay, let's try it again down here. I'm going to write the limit as delta x approaches 0 of, let's break this into chunks. We start with f of x plus delta x. So let's imagine what that would look like. What is f of x plus delta x? That'd be 5 over, right? Everywhere we see an x before, now we're going to replace it with x plus delta x. So I'm going to write that down here, 5 over x plus delta x minus, I have a minus sign, so I'm going to put minus f of x. Remember, if f of x is more than one term, you need to make sure that you put it in parentheses. Okay, here it's not really necessary because f of x is just 5 over x, so we'll leave it like that. All over delta x, and there we go. Okay, now I can't just leave it like this. What would happen if I plugged in 0 right now? Well, if I plugged in 0 for delta x, I would end up with 5 over x, right, because delta x is 0, minus 5 over x all over 0. See how we get 0 over 0, which is indeterminate? So I know I have to rewrite this into a simpler function. So I'm immediately thinking to myself, how am I going to get a simpler function? Well, I'm going to multiply by a least common multiple. What least common multiple should I multiply the top and bottom by? Well, here the denominator is x, and here we have a denominator of x plus delta x. Okay, so down here, really, this is over 1, so the denominator is 1, so I'm not going to include that. Okay, not only am I going to multiply the top by that least common multiple, but I'm going to multiply the denominator by it as well. Okay. If I multiply this through to the first term, what would cancel? The x plus delta x's would cancel, so it would just leave me with 5x. Okay, if you can't imagine that in your head, it would look like this. Okay, and then you could cancel top and bottom to get 5x. I normally don't write that step out. Okay, multiplying it through to the next term, what would cancel? The x's would cancel, so it would leave me with 5 times the quantity, x plus delta x. Okay, again, if you can't imagine that, write it off to the side. We would multiply by the least common multiple, and we would get something that looks like this. So you can see the x's would cancel, and it would leave me with the negative 5x plus delta x. X plus delta x being inside parentheses. Make sure you don't forget those parentheses. Okay, all over, and this is the step I always forget. You have to multiply the denominator by the least common multiple as well. So we get x times delta x, and then I just leave this factored, so I leave the x plus delta x in parentheses. Do not, and I repeat, do not cancel at this step. The numerator is not factored, so you cannot cancel yet. We have to multiply everything out and combine like terms, get the numerator in factored form before we can cancel. Okay, so I'm going to rewrite this limit as the limit of 5x minus 5x, distributing. We get minus 5 delta x all over x delta x times the quantity x plus delta x. Okay, the 5x's cancel. Take a look at what I have left now. I have a negative 5 delta x in the numerator, and I have x delta x times x plus delta x in the denominator. So look at what we've got. This is multiplication, so we can cancel the delta x's, reduce that. So now I've got negative 5 over x times the quantity x plus delta x. And I think that's about as simplified as we can get it. Notice I carried my limit notation all the way down because I have not plugged in 0 yet for delta x. So now I'm going to go ahead and plug in 0 for delta x, and we'll drop our limit notation. Negative 5 over x times the quantity x plus 0. So we get negative 5 over x times x, or negative 5 over x squared.